Hello everyone, welcome to our statics solution series, and in this question we are going to find the resultant moment of a force system acting about a point. So let's go over briefly what the question is and let's analyze everything one by one. So we're going to find the moment of those four forces about the point O. And what are those four forces? So the first one is with a magnitude of 50 newtons and it is acting 2 meters away from the application point. The second moment is having a magnitude of 60 newtons and it is passing directly from the point O, which we need to be very careful because this will create no moment about point of application. The third one is the moment with the magnitude of 20 newtons. It is acting at the end of a rod, which has a length of 3 meters. And the fourth force is having a magnitude of 40 newtons. And we're going to find out the moment arm using the geometry given to us. What is the geometry? So the straight line is divided equally 2 meters by 2 meters, so it is 4 meters in total. This extra rod has a length of 3 meters with an angle of 30 degrees. What is the question? Determine the resultant moment of the four forces acting on the rod about point O, about this point. So let's move on to the solution. For the sake of this question, we are going to assume counterclockwise moments as positive moments. What do we mean by counterclockwise is that the moment action created by the force will be in the direction of counterclockwise, so in the opposite direction of the clock movement. To find the answer, we need to find the moment of each force with respect to the point O, and we need to sum them up. First of all, we need to recall the formula for the moment. Well, how do we find the moment of a force? Well, we multiply the force with the moment arm. So we need to identify two different variables. The first one is the magnitude of the force, which is given to us in the question directly. And the second one is the moment arm, which sometimes we may need to find those through geometric interpretations. And we need to be careful because moment has a sign. If it is acting under counterclockwise, we are going to take it as positive. If it is in the clockwise direction, we are going to take it as negative moment. So let's go over how to find the moment of each force one by one. Let's start with the moment created by the 50 newtons. So we know the magnitude and we need to find the moment arm. So this is fairly simple. The moment arm in this one is 2 meters because the perpendicular distance between the force application point and the moment reference point is 2 meters. Well, the perpendicular distance, as you can see, is 2 meters here. So we're going to multiply 50 newtons by 2 meters, which gives us 100 Newton meters. And the convention we use for the moment is in terms of force times meters. So in this one, it's Newton times meter. And it is acting as in the negative direction because it is acting in the clockwise direction. How do we find that? The moment, as you may recall from your right-hand rule, this force is acting and causing a moment in the clockwise direction. So the second moment we need to find is for the 60 newtons. Be careful because, as we have mentioned, the moment arm is the perpendicular distance between the force and the reference point. And in this one, the 60 newtons is acting directly from the point O. So the force is passing right from the point O. So the perpendicular distance is 0 because there is no perpendicular distance in this force. So the moment arm in this case is 0, so the moment created by 60 newtons is 0. An explanation, moment arm is 0 because the force is passing right through the point O. thus creates no moment in the system because the perpendicular distance from the force to the reference point is 0 in that case. Let's go to the third one. We're going to examine the 20 Newton force. So how do we find the moment arm? What is the perpendicular distance? In that case, we need to find the perpendicular distance between the force and the point O, which is this distance, the distance here. Why? The force is acting in this direction, in horizontal, so the perpendicular distance should be vertical. And since we are given the 3 meters and 30 degrees here, we can easily find this vertical distance, which is 3 times sine 30 from the sine rule. So how do we find the moment? It is 20 newtons, the magnitude of the force, times the perpendicular distance from the moment to the reference point, aka moment arm. So the moment arm is 3 times sine 30, and the moment created by the 20 Newton force is 30 Newton meters. And it is acting in the positive direction because, as you can sense from your right hand rule, 20 Newton force is creating a moment in the counterclockwise direction, as I am trying to show with the red dot on the screen. It is, as you can see, in the counterclockwise direction. Let's move on to the last force, which is 40 newtons. And just let's guess what is the perpendicular distance. And it is that distance here. Why? The force is acting like this. And when we draw a 90-degree angle and calculate the distance to the reference point, it is this distance. The perpendicular distance is here. So it should be 4 meters plus the distance of this little triangle. And how do we find that? Again, we need to use the 3 meters and 30 degrees. So the moment arm becomes 4 meters, which is coming from the rod on the upper side, and plus this little triangle bottom length, which we found using the trigonometry, which is 3 times cosine of 30. So when we multiply 40 by the moment arm, the moment created by this force is 264 Newton meters. Again, it is acting on the negative direction, so it is acting on the clockwise direction. Why? As you can sense, and I'm trying to show it with the red dot again here, the force is trying to create a moment in the clockwise direction. So since we made the assumption that the counterclockwise moments will be positive, the moment created by the 40 newtons will be negative. So how do we find the resultant moment, which was the question to us? We just sum all of those moments up, m1 plus m2 plus m3 plus m4. We need to be careful about the signs that we are using here, because each of them, the moment, will have a sign depending on the direction it is acting. So m1 is minus 100 because we found the magnitude as 100 Newton meters, but it is acting in the negative direction, so it is minus 100, minus 100. The second moment was 0 because the moment arm was 0. The third one was 30 Newton meters, and it is plus 30 because it is acting in the counterclockwise direction. And the last one is minus 264. It is minus because it is acting on the clockwise direction, and we have assumed that the counterclockwise is the positive convention. So again, it is negative. What we find when we sum those up, we find negative 334 Newton meters, which means the moment has a magnitude of 334. And since it is negative, it is acting in the clockwise direction, as I'm showing here with the arrow. It is acting in the clockwise direction, which implies the negative sign at the front of this number.